Hi class, this is Mr. Krieger. This is Unit 14, Lesson 3. We're going to do more practice with the chi-square test of independence. By the way, this will be the last new lesson that we do, and then we'll start reviewing for the AP exam. As you might have known, I sent you an email. We don't have to cover the last two topics. That actually includes this topic, but I thought since we're just about done with it and it's such an important thing that you can benefit from in college, I thought we'd just finish this lesson up and then we'll move on to AP practice. So one of the things we were going to explore a little more today is the conditions for the chi-square test. First of all, the data must come from a simple random sample of the populations of interest, and then you've got to check the expected counts. Here's a quick check. All the expected counts should be greater than or equal to 5, but you can get a little more flexible if you look at your counts, your expected counts more carefully. As long as all of them are greater than 1 and no more than 20% of the counts are less than 5, you meet the condition. So let me just show you two examples so you can see what we're talking about. So number one is okay. Here's an expected counts matrix. There are 6 cells here. Only one of the 6 cells is less than 5. If we take a ratio of that 1 over 6, it's 17% of the cells. So that's less than 20%. So we could go ahead and do the chi-square test in this particular case. This is not okay. Here we have 6 cells. 2 of them failed to meet the condition of being more than 5. They're all greater than 1, but 2 out of the 6 are less than 5. That's 2 6 or about 33% of the cells are less than 5. Do not use the chi-square test there. So what we're going to do now is we're going to, please print up this lesson. This is lesson number 3, which I sent to you. It's just more practice with this chi-square test of independence. And this is actually an AP problem, so I thought we would take a look at it. Here we have product advertisers studied the effects of TV ads on children's choices for 2 new snacks. Advertisers used 2 30-second TV ads in an experiment. One ad was for a new sugary snack called Choco Zooties. It's a chocolate snack. And the other one was for a healthy snack called Apple Zooties, an apple snack. For the experiment, 75 children were randomly assigned to one of 3 groups, A, B, or C. Each child individually watched a 30-minute TV program that was interrupted for 5 minutes of advertising. The advertising was the same for each group with the following exceptions. The advertising for Group A included the Choco Zooties ad, but not the Apple Zooties ad. The advertising for Group B included the Apple Zooties ad, but not the Choco Zooties ad. And the advertising for Group C included neither ads for Choco Zooties or Apple Zooties, okay? So here's what we see. We have this matrix. We have Choco Zooties ad. Number of children who chose from Group A, Choco Zooties, was 21. Number who chose Apple Zooties was 4. Now look at the Apple Zooties only ad. If the children saw Apple Zooties ad only, 13 chose Choco Zooties, but 12 now chose Apple Zooties. And if they weren't shown either ad, 22 chose the Choco Zooties and only 3 chose the Apple Zooties. So clearly it seems, to us at least, that the Apple Zooties only ad actually had some effect on the outcome of the children choosing the healthier snack. With the Choco Zooties ads or the neither, more kids were choosing the more sugary and less healthy snack, the chocolate snack. But with the Apple Zooties ad, it seems like more children were picking the Apple Zooties. But anyway, is this significant or not? So we're going to have to make our expected value matrix. Again, we also have to check that it was a random sample, but this was actually an experiment involving children separated into groups. So let's go back and let's recall how to put this data into our calculator. We're going to go to the matrix. This matrix, you go to edit. This matrix is a 3 rows by 2 columns, so it should be a 3 by 2, in which we put in, all the numbers, 21, 4, 13, 12, 22, 3. And now we're going to write down our expected values matrix by running the chi-square test. Go into stat, tests, go to the chi-square test, not the goodness of fit, but the regular chi-square test. Everything should be set up properly. We'll take a look at the information later, but in the meantime, what I want to look at is the expected values matrix. I'm going to go back to the matrix. I'm going to go down to edit. I'm going to go to B, and there's the B matrix. I'll write it down for you so you can see it. I'm not making it fully here. I'm just going to show you what it is. This is what I'm thinking. These categories are over here. These categories are over here. So for the Choco-Zooties ad and those who chose it, for the expected values was 18.7. And I'll just go down the list. This was 18.7 and 18.7. And this was 6.3, 6.3, 6.3. What we can do is we can say to ourselves, okay, all of these are greater than 5. So we've met the condition, so we can proceed with the chi-square test. Now it asks, do the data provide convincing statistical evidence that there's an association between the type of ad and the choice of snack? So let's go back and run the test again. I'm going to go stat test, going to go to the chi-square test, run it one more time, and here's what we've got. We've got a chi-square value of 10.29 and a p-value of 0.0058. Well, we should be able to say in this case that with a p-value so small, we can reject the null hypothesis. Now, we didn't write down the null hypothesis here. The null hypothesis would have been there is no association between type of snack that children chose and the type of ad they saw. We would have to reject that hypothesis with such a small p-value, and we would write an appropriate conclusion here. Write a few sentences describing the effect of each ad on children's choice of snack. Clearly, with a p-value like this, the Apple Zooties ad had a pretty big effect on encouraging children to eat the Apple Zooties. With chocolate Zooties ads only or no ads only, children weren't likely to pick that snack. But with the Apple Zooties ad, it clearly did have an effect. All right, we're going to try one more problem. This is a study of music on wine purchases. Market researchers know the background music can influence the mood and purchasing behavior of customers. One study in a supermarket in Northern Ireland compared 3 treatments: no music, French accordion music, and Italian string music. Under each condition, the researchers recorded the number of bottles of French, Italian, and other wine purchased. Here's a table that summarizes the data, and just to put you in the mood, I'm going to play some French accordion music. Maybe you've never heard some before, but I'm sure you have. All right. So, here's what's happening. This is the type of music played, none French or Italian. Here's a type of wine purchased. If no music is played, 30 French wines were purchased, 11 French wines, and 43 others. If French music is played, then 39 French wines are purchased, 1 Italian wine, and 35 other. And if Italian music is played, 30 French wine is sold, 19 Italian wine. Seems like Italian music might have an effect on the Italian wine. But anyway, these numbers don't look like they've changed so much, so let's run the test. We need to do our expected counts matrix. This is going to be 3 by 3. So if we go to our matrix, edit, and we're going to do 3 by 3. I'll put in the data here. So we've got 30, 39, 30, 11, 1, 19, 43, 35, and 35. Okay, I'm going to run the test now, stat test, chi-square test. And let's take a look at that expected values matrix. I'll write them down. Please, you've got to write this information down. We got 34.2, 30.6, 34.2, 10.7, 9.6, 10.7, 39, 34.9, and 39, actually 39.1. And again, I'm not doing the full thing here. We have to check the conditions. Where's this SRS? That's the first check you would do. Are all these counts more than 5? They are. Our null hypothesis, okay, I guess our music is over. That's fine. Our null hypothesis is no association between type of music played, and wine type purchased. And you know the alternative will be there is an association between type of music and wine selection. Let's take a look at the data. Going to run the test one more time. Chi-squared test. Let's take a look at that chi-squared value. The chi-squared value is 18.28 and a p-value of 0.001. This is a very, very small p-value. You should know at this point, this means to reject the null. There is an association between music being played and type of wine being purchased. So we would say we reject the null in favor of the alternative. Music actually has an effect on wine purchases. Okay, so the next time I come back, we'll be working on review for the AP exam. I'll certainly be in touch with you and let you know what you should be doing. Do this homework. I think it will solidify this understanding. I think this is a really important thing to understand when you go into college. All right, guys, till next time.